Welcome aboard, ladies and germs. My name is Eric. Today is Saturday, March 8th, 2025, and it is 1600 hours Eastern Standard Time. And today we are going to continue our pattern of not working on the Kraken bot, and instead I'm going to show you something else, as usual. So this week I have gotten some NVIDIA GPUs working on my Kubernetes cluster, and I want to show you how that works and what I have done. Let's see. First thing I want to do is show you that there's a bit of a history to this. We're going to start our adventure today over on Gitea, git.eom.dev. This is where I host my code, and you are welcome to log into this using your Google account. And anyway, so this has been a long time in the making. If we look at our issues over here, there's 3 closed. One of them is the RTX A6000. So the NVIDIA RTX A6000. Let's look at that GPU. That is a big GPU. Typically used in data centers and AI workloads. I think it has 48 gigabytes of VRAM. And it requires 300 watts of electricity. It's one of their more recent GPUs, very powerful. We're not going to look at all the specs. You can Google it. Very expensive, very big, very powerful, single GPU. I ordered it, and it worked on my Arch Linux system, but when I switched over to Debian for this Kubernetes cluster, the drivers don't work. Neither the ones that come with in the Debian repositories, nor the proprietary ones provided by NVIDIA themselves. In both cases, I would get this issue of RM init adapter failed. And I tried a number of things to resolve this. I thought maybe there was a problem with the cooling, so I got an additional external fan and attached that to my PowerEdge T640. Excuse me. That did not solve it. I additionally, if we come down more recently, I attempted to install 2 1100 watt power supplies in the T640, and while I am still using those, they did not resolve this issue either. So eventually I decided to try a different GPU, and so this week I ordered a Tesla T4. We have a new issue created on Gitea. And this one is to install and test out the Tesla T4. Let's look at them side by side, kind of. We'll see if we can do that. By comparison, we could probably pull up their spec sheets. Yes, this is the Tesla T4. By comparison, it's much smaller, whereas the RTX A6000 is 300 watts of electricity. The T4 is 70. Additionally, the A6000 has a built-in fan, and additionally I had a separate external fan in addition to the, I think, 6 fans that are inside of a T640 to begin with to cool this thing. So it draws a lot of electricity, it gets really hot, requires a lot of cooling, and it was pretty loud. This is passively cooled by the fans that exist within the T640 already. I think this one was 48 gigabytes of video RAM. This one only has 16. I think we can look at the actual data sheets, and that might show us a little bit more interesting side by side. Here we go, perfect. I was afraid they were going to give us a lot of tedious information that would not be well, maybe we still have to, might still have to dig here. Yeah, we're not getting exactly the same chart, but I guess you can pause the video and see some of the specs here. They both have CUDA and tensor cores. I think the A6000 has some other kind of core that is a little bit more powerful. It does not say here exactly, I don't think. Yeah, 48 gigabytes of memory. But anyway, point being, Tesla T4 is much smaller, much less expensive, much lower power draw, but it's still a pretty powerful data center GPU. If you use, I think, Google Colab, the GPUs that come with Google Colab are Tesla T4s. So this is the one that Google Cloud uses. So it's still a very good GPU, but it's much less expensive. So I only have one at the moment, but what I'm thinking about doing, planning to do, is selling this A6000 and using the proceeds to get an array of these Tesla T4s. Hence the need to put them in a Kubernetes cluster. So if you're interested in following along with the history of these things, going into Gitea and looking at some of these closed issues, there's some documentation that I have linked, and also I comment on the errors that I'm seeing. So if you're having errors, you may find something in here. But what I want to show you is using the actual T4 on my PowerEdge server. So I'm going to pull up some documentation here. My server is a Dell PowerEdge T640 running Debian 12, and this article, I will link it in the description. I'm actually going to copy this link right now so I don't forget that. And I should also take a timestamp here. Okay. So, in order for all this to work, if you recall from some of my previous videos, my setup is a big server, the T640. I have 15 virtual machines running on that T640, and those are all configured into a single Kubernetes cluster. Now, what I have done is I have taken this Tesla T4 and I have used this VGA pass-through to give it to one of the virtual machines that is part of the cluster. And then we configure the cluster so that it knows that the GPU is available and it can be requested by services that are deployed to Kubernetes. First step of all of this is this VGA pass-through. And there is kind of a lot of setup here. This part wasn't so bad. My host system worked pretty well out of the box. I already have QEMU and KVM installed. I already had my virtual machines running. This was just a matter of installing the GPU. So when I first started this, I had an NVIDIA driver installed on the T640. We'll see in a moment that I ended up having to uninstall it. So first of all, on the host OS, I had to edit the grub command line arguments so that it would turn on Intel IOMMU, and then you update grub. Was there another step there? No, I don't think so. Anyway, so the next step is to assign the well, actually, first of all, this is where I uninstalled the NVIDIA driver. So what you need is to have, it should say it right, blacklist and reboot. We do not want the drivers for the guest card to be loaded on the host operating system. So the first thing I do is blacklist them. Let's see. NVIDIA or blacklist? Blacklist nouveau. So I uninstalled the NVIDIA drivers, purged them from the system, uninstalled CUDA, all of that stuff. It's all gone from the T640, and I blacklist the nouveau driver, which would load by default with this NVIDIA GPU installed. Okay, and with that done, we can then assign the VFIO driver to the GPU. Manually, this is done. First, you need to get the vendor and model of your card. Here is the command. Again, I have this document linked in the description. You'll grab these two numbers here, and you will put them into this command. No. This command. Excuse me. In the example here, they have a GPU and a audio device, and not really the greatest example because it makes it seem like you always have to do this for two things. But in my case, there is no audio device on the GPU. So I load the VFIO driver, I load the VFIO PCI driver, and then I run exactly this command with the numbers pulled from here just once for the one GPU. If we want to see what that would look like, we can put it in here. This one down here, here is the number, and I think if I just do echo, it should show us. Yep, that's exactly what I did. Just that one command. Okay, so that is going to load our VFIO, or assign the VFIO drivers to the GPU on the host operating system. So that way the host operating system doesn't really do anything with the GPU, it just gives it off to a guest. And in the example that's given here, they show you the QEMU command for assigning this device to your guest. It's right here. In my case, I happen to use Virt Manager. I'm a big supporter of doing this from the command line, but I wanted this to be a little bit easier. Since I just opened up Virt Manager, and so I have to type in a password. I already know how to do these commands, and it's a little bit easier from Virt Manager. So I just decided to do that. So if we open this, first of all, this is a remote connection that I set up on Virt Manager. Add connection. You can do a remote. You need to add your user to the, I think, libvirt group or something like that. But you just log in with SSH to whatever machine you're interested in. In this case, we are logged in to the T640 from the Inspiron on my desk. And here we can see Alpha Worker 0 is the one to whom I assigned this GPU. So if we open this, which I already did here, it's right there. This I cannot make bigger for you, I don't think. So I don't want to like power it off by accident, so I'm not going to try. We don't really need to read what's written on this screen so much. So anyway, I do view, details, and then I say add hardware, PCI host device, and then I scroll all the way to the bottom of the list, and I have this Tesla T4. I'm not going to do that because I've already done it on this, but I just added it there. And since the VFIO drivers have been assigned to the GPU in the T640, it is assigned to Alpha Worker 0. I think I rebooted Alpha Worker 0 after that. That's not wildly important because the next step is to set up the guest. I don't think I want a timestamp just yet. So that is a simple matter of installing the NVIDIA driver. The NVIDIA driver, let's see. I'll also link this documentation. It's pretty simple. You install a few kernel headers here, Linux headers, AMD 64. I think you also, well, you'll see that in a second. I'm on 12. You're going to enable the non-free repositories, update apt, and then install just NVIDIA driver, firmware, miscellaneous non-free. I also installed the CUDA driver because my thing can use CUDA. But yeah, once you have those installed on your guest, which I've already done, we can SSH into that machine. Here's Alpha Worker 0, and then if we do NVIDIA SMI, the Tesla T4 is running on Alpha Worker 0, our virtual machine guest. We have successfully done VFIO pass-through of a GPU to a guest. Hooray. But just because it's on the guest doesn't mean Kubernetes knows it's there. So the next step is to make this available within the Kubernetes environment and make it so that we can request this resource. So let me take a quick timestamp. Windows, not the operating system, as in like I have multiple windows open. Okay. So the next step is going to be taking this GPU that is available within our virtual machine guest. We have done our VFIO pass-through, and we want this to be available within Kubernetes so that we can request it as a resource for our services. And there are a few steps to this, and the documentation, well, we'll see. Here is the main page of documentation. Whoops. Wrong window. This is the main page of documentation for scheduled GPUs on Kubernetes. I am going to copy this link into my description so that you can have it later. It's okay. A lot of this depends on what kind of GPU you are using, so there are some choices you have to make. I'm using NVIDIA, so that's all this video is going to cover. But this documentation is a little bit confusing. I found it a little bit difficult to follow. Anyway, the first step is to use device plugins. We need, let me check my notes here, make sure I'm covering everything. No, I missed a few things, but that's okay. They're not important. Okay, so device plugins. The first thing we have to do is set it up so that the underlying container system can use NVIDIA. In this case, we can go to the NVIDIA link here. This part's also pretty confusing. So this repository, let's pay attention to the name here, K8s device plugin. So we're installing the device plugin. We also need to have the NVIDIA Container Toolkit and NVIDIA Container Runtime. So this we actually need to do first. It does not say that in our, I don't think it says that in our documentation here. It doesn't. So this guide we actually need to follow first. So I'm going to copy the link. I probably won't label the links in there. They'll probably just end up being first come, the order they appear in the video. Okay, so this page is going to document how we are going to install the container toolkit. It's very easy on Debian. You're just going to add this GPG key, add this repository to apt, and then update and install NVIDIA Container Toolkit. We do need to configure it though. So it depends on what kind of underlying container system you are using. Docker is the most common, but not for Kubernetes. I don't think it's even an option for Kubernetes anymore. I could be wrong about that. But Docker is probably not what you were using if you were using Kubernetes. Containerd is probably the most common. I don't remember what the other one is. There's another one, but I don't know it, and we're not going to cover it. So Containerd. After we have installed this container toolkit, we need to set the Containerd runtime to be NVIDIA. And actually, it's helpful to, on mine, I went ahead. I don't see, where's that option? If I look at the actual command that I used, what was it? I'm missing it already. NVIDIA CTK. I added this set as default to the end. It comes in later when we're trying to deploy our services, but basically this is just saying that the containers on this machine are going to use the NVIDIA toolkit by default. So we have to configure Containerd to use that runtime, and then we have to restart Containerd. Once that is done, we can return back here to install the container toolkit. What's the difference here? Yeah, see, it's kind of confusing. NVIDIA Container Toolkit versus, this is the K8s device plugins. Okay, so we have installed the container toolkit and the container runtime. So now we need the K8s device plugin, also specifically configured for container D, I think. Sorry. Let's see, where is the Helm chart for this? I think it's down a little further. Sorry, this is a bit big for my position to it. So. No, none of this is what I'm looking for. Here it is. Perfect. These instructions will, I don't want to move away from that, but these instructions are going to show you first how to use it with just like a kubectl apply with a URL linking to something, I don't know. But you know, the way to do it in a production environment is to use Helm charts. And here we can use this K8s device plugin Helm chart. And that is indeed what I did. Let me check my notes here. I'm going to come back here. Okay. Make sure I am... Okay. Yeah, so this is where things were a bit confusing again. The device plugins, it just makes your device of... I'm actually not entirely sure what it does specifically. It kind of just provides the back end for your GPU to work with Kubernetes, but there's a lot of other things that need to happen in order for Kubernetes to actually use it and for services to request it. So the documentation here is also telling us to just install this device plugin. However, I found, where did I find it? It's here. This guide is very helpful. I will link it as well. Let's check the author because I think it was written by a single person. Jim Angel. Thank you, Jim Angel. This was very helpful to me. I'm putting the link in my description. Okay. So the device toolkit gets you halfway there, and the documentation only tells you about the device toolkit. So if we look at this here, yeah, this is telling us how to install this device plugin, device toolkit, whatever we want to call these things. It's a bit weird. But what we actually need is something else. We need that. Configure container D. The GPU operator. Okay, so this is something else. So first we have this NVIDIA container toolkit, which we then configure container D to use. And then we are told by the instructions over here to install this K8s device plugin, but I found that that did not get me all the way. I was not able to see the GPU on my node after I installed just this. I needed to install this. It was right here a second ago. The GPU operator, which includes the device plugin. Okay, so installing the GPU operator instead of the device plugin. The device plugin comes with the GPU operator. So if we look at, so this is the Ansible role I used, Ansible role I used to deploy this. Originally, I was using this device plugin repo. So you can see I followed the instructions here, NVDP, and I installed that. But then I found that it wasn't working. So I forgot to change the name up here, but I did put the right URL here to get me to the GPU operator. Let's see. Ooh, where to go? That's the wrong page. Here's the GitHub repo, official instructions. You can look at the values there. That just tells you how to install Helm. This is our GPU operator. Does it give us instructions? That's a helpful picture, I suppose. I don't know. Anyway, I used Helm once again to deploy this, and actually I didn't need to set any values. I already had the toolkit installed. I already had the NVIDIA driver installed, so I just turned those to false, as was suggested in this practical guide, which I found to be the best guide to this. And from there, once that is deployed, the GPU operator actually can see a lot of information about your GPU. So we can go over to the control plane, and we can do describe node, alpha worker 0, and we can look at these labels, and if we just scroll down a little bit, we have CUDA driver information, we have GPU information, we can see that the GPU product is a Tesla T4. So we can see that Kubernetes now can see our GPU. I just want to reiterate one more time because I know it was confusing. If we start from the instructions here, we are going to install from NVIDIA our device plugins, this container toolkit, and the container runtime. We will follow the instructions here using this curl command and simply apt install the NVIDIA container toolkit. And then we are going to configure containerd to use that runtime. Okay, then we are not going to install the actual K8s device plugins that are suggested. We are instead going to install this GPU operator, which exists on one of these tabs somewhere. We're going to install this GPU operator. Once the GPU operator is installed in Kubernetes, I think I'll just show you the Helm chart one more time so you can see my values, where they go. Well, I think they're gone. Oh well, that's fine. There they are. Perfect. So here is the actual deployment of that Helm chart. Not a whole lot you need to do to change these values. You just pretty much as is. Since we already installed these extra things, we don't need to do it again. We set that to false, blah, blah, blah. Okay. Our GPU is working. Kind of. Let me take a timestamp. Okay, so the next step, once we have the GPU visible in Kubernetes, and let me just show you one more thing with that. We'll go over to the control plane. We're going to describe our worker. Let's go down a bit, and we can see allocatable. We have, oh, well, it's saying there are 0 GPUs available. Let me check something real quick. That's not what I expected. I don't know. That's unusual. It was saying there was 1 a while ago. Well, anyway, I'm going to ignore that. Usually down here it will tell us that there is 1 GPU available. I'm not sure why it's saying there aren't any at the moment. There's another command we can run just to make sure. And I'm going to have to redo my timestamp here. But if we go back to our practical guide, we can take this command. Hold on. Uh-oh. I actually just got this set up this morning, so I'm not totally surprised that some things are a little bit odd. And I don't know my way through this document particularly well, so. Let me just see. Well, anyway, I'm going to move on. I have a little more debugging to do on all of this, but that's okay. Let me change my timestamp here. Okay, so once our GPU is available in Kubernetes, we need to actually request it to be used by a service. And we can see how that's done in this. So here I am trying to deploy local AI. This is an application, I guess it's a clone of OpenAI. It provides the same API structure for open source AI models that you can get from Hugging Face or other places, I don't know. Anyway, again, we use a Helm chart to deploy it, and there are a few things that I do. First of all, I set in our values resources limits nvidia.com/GPU. I'm asking for 1. You set your request in a limit. There are limits and there are requests, and you're going to specify it in a limit, not a request. So there's that. Also, I have added a taint to my my node, my Kubernetes node. We can see if I describe that node. Taints. I set a specialization equals GPU with the effect of no schedule. And this makes it so that any other services that I deploy, any other pods that exist in this cluster, they are not going to be deployed on this node. So by default, everything is going to avoid being deployed on Alpha Worker 0. So I have set that taint. And the reason I have set that is so that here, when I deploy this service and I request a GPU, I can set a toleration that if our specialization is GPU, that we are allowed to schedule on that node. So in this case, we are able to specify which services we want to run on our GPU-enabled nodes using our tolerations and taints. But this is basically how we are going to request our GPU now that it is available in Kubernetes. And if we go over to our local AI, I showed you that in a little second ago, we can look at our pods and it's pending. It's not there. What's going on? If we look at the problem, I need to move this up. So it says there are a few problems. First problem is the untolerated taint that it is a control plane. So it's saying that it will not deploy this on the control plane of the cluster, which is good. We don't want that. Another node has this taint, the disk pressure. So there's one node in our cluster that has high disk pressure, and we cannot deploy to that node. There are 12 that do not have an NVIDIA GPU. And then there's the option for removing certain pods from ones that are busy, but that's not going to help anything. So this one is just sitting around waiting for a pod to become available that has a NVIDIA GPU that it can claim and doesn't have too much disk pressure, which alludes to the problem that I'm having. If we go over to Alpha Worker 0 and we do df-h, we can see up here, I've reduced it to 87%. But this virtual machine has only 16 gigabytes of disk space, and after I installed the NVIDIA drivers, we were cutting it really close. It was at like 98% of disk space, and then I pruned the logs. I rotated my journal. I pruned my containers and images, and that brought it down to 13 out of 16, or 87%. so it still can't run. But the problem is not the GPU. If we were not able to run, if it was missing the GPU, we would have 13 nodes that have insufficient NVIDIA GPU. So there's 14 total. One is a control plane. One is Alpha Worker 0, which has this high disk pressure. And the other 12 have no GPU. So I need to fix this problem here. Once I fix this, local AI should be able to run, and we should have a GPU running in a Kubernetes cluster. I don't think I made it particularly clear why I would want this, but at the beginning I was saying how I have that one A6000 over there, and I can exchange that for maybe even 4 Tesla T4s, and that is much more suited to a Kubernetes environment. I can have multiple services using the GPU at different times depending on what's being done, and it makes the whole network a lot more dynamic with how I'm going to use these GPUs. So I have created another issue on Gitea. We'll see it here. This is referring to disk pressure on Alpha Worker 0. And then I also have another issue for deploying local AI. These are both in progress. I have set one as dependent on the other, and I will be working on this more in the future. Krakenbot will come back, but yeah, this was a little bit more exciting this week, so this is what we're doing. Aside from that, I'll just take a moment to remind you that once I have concluded the stream, it will go onto Discourse in a post. You can visit discourse.eom.dev. You can sign in with your Google account, and you can comment on anything that I post here. You can make posts of your own, and I'm going to be doing more stuff with this in the near future, but I'm not quite ready to announce that yet. Okay, I think that is all we have for today. I thank you for joining me, and I will see you next time. Toodaloo.